Well, it's no surprise to all of us that the planet is going through a polycrisis. I think for the first time, humanity is facing several crises that are occurring at the same time. Climate change, biodiversity loss, pandemics, armed conflicts, different economic crises and food crisis. And these crises are not happening by chance, but they are kind of the consequence of a development path that humanity chose. And actually, because of these economic activities, extraction of resources and exploitation of nature, we have actually transgressed six planetary boundaries. A group in Stockholm developed what is called the planetary boundaries. The safe operational space of humanity is this green area. And you can see that in terms of freshwater, land systems, biosphere, integrity, climate change, and contamination with novel entities have already surpassed in safe operating space. That means that these processes are irreversible and that humanity will have to learn with the consequences of transgressing this I don't hear what you're saying.
Sorry, Professor Altieri. This was someone with their microphone.
Okay, can they turn it off, please? So anyway, so we have to adapt to this new situation, this new planetary situation where boundaries have been transgressed. Climate change is irreversible, and therefore we will have to learn with live with the consequences of this process. We are now experiencing severe droughts, extreme precipitation events, heat waves, coastal flooding. There's very strong scientific evidence that shows that these have been human caused. The year 2023 and actually 24 also were the warmest years ever detected, in which during 180 days temperatures went above 1.5 degrees centigrade threshold established in the Paris Agreement. And what is interesting is that despite the fact that there has been more than 28 COPs, the greenhouse emissions have increased 65% since the countries sat down to negotiate. So all these agreements have not really served the purpose of limiting emissions. And now with Trump getting out of the Paris Agreement, the question is whether humanity can really afford 4 years by the second largest polluter to continue emitting gases into the atmosphere. As a matter of fact, you can see here that the responsibles historically for climate change, the countries that have been the producers of climate change, have been United States, actually, China recently in the last 25 years. But you can see that China per capita consumption or emission of tons of greenhouse emissions is 9.7 as opposed to 19.27 per capita in the United States. And then follows India, but per capita you can see is very low, and the Russian Federation, which is about 16. So what's happening is that there's a climate injustice because the warming that has been caused by the huge consumption on the part of the rich countries has had repercussions on the poorest areas of the world. And climate change is affecting the most vulnerable people on the planet who contributed minimally to global environmental destruction. And one of the issues that is going to come up by the year 2050 is that there's going to be a climate migration. It is expected that there's going to be about 1.2 billion refugees, climate change refugees around the world. And with Europe and the United States closing their borders, where these people are going to go? That's a big question. And they have to leave their countries because of climate change that was not caused by them, but by the rich countries. So humanity is facing a series of global problems. energy shortages, biodiversity loss, climate change, etc. And these problems cannot be addressed in isolation because these problems are systemic, they are interacting, they are interdependent, and when one problem is aggravated, the effects spread throughout the system, exacerbating other problems. For example, if we look at the relationship between climate change, the pandemics, and economic crisis, well, the underlying causes of the pandemics are the same underlying causes of that drive biodiversity loss and climate change, which is really the capitalist mode of production, extraction and consumption, with a metabolism that is out of tune with nature's regenerative capacity. So the pandemic induced a health crisis, quickly triggered an economic crisis. And this crisis, this economic crisis and health crisis, was unfolding in the context of a climate crisis, which exacerbates the pandemics and the economic crisis. So they're all interrelated and reinforcing each other. So we could say that at this moment of ecological and economic rupture, the pandemic and climate change constitute a manifestation of a cascade of catastrophes that will continue impacting humanity as long as we continue in our path of extraction and consumption. And this rapid expansion of industrial agriculture and the disruption of natural ecosystems that imposes a huge ecological toll on the planet is part of this cascade. And what I'm going to talk about is how agriculture is affecting the environmental integrity and what are the solutions to get out of that problem that is caused by industrial agriculture. So in the world, we have about 1.5 billion hectares of 80% of the 1.5 billion hectares of agriculture in the world are under this very large-scale, ecologically narrow, homogeneous monocultures, which lack ecological stability, and therefore they need to be constantly be managed with inputs from the outside, pesticides, fertilizers, energy, etc. And they're very vulnerable to climate change, to pests, to insects, to weeds. And despite the fact that we could be eating more than 250,000 species as humankind, actually three crops that dominate most of the landscapes of the world, rice, wheat, and maize, provide more than 50% of the human food. And this is not because we love just rice and wheat and maize, because there is a whole economic system that has basically narrowed the dietary options of humanity to these three crops. And as you can see in this graph, as we diminish the diversity of crops in a landscape, you will see that the possibilities of harvest loss by insects or pests or weeds or climate change are higher. And as we increase the diversity of crops in a landscape, then the dangers, the probability of harvest loss diminishes. But here, humanity is around one or two species dominating landscapes. And that puts agriculture in a very dangerous situation in terms of probability of harvest loss. So because of that, the fragility of the systems and their vulnerability to diseases and insects and so on, we have to use more than 5.2 billion pounds of pesticides that are injected into the biosphere constantly every year. And if we account for the environmental impacts and the health impacts of these pesticides, just in the United States, it would be about $10 billion. And you can see that pesticide use is going up, even in Europe, which has a lot of environmental regulations. And despite the injection of these pesticides into the environment, the annual crop losses caused by insects, weeds, and diseases is about 40%. So we're using tools that are not effective, that they're contaminating the environment, and they're causing major health problems. And in addition to that, agriculture, especially industrial agriculture, contributes more than 30% of the global greenhouse emissions. And paradoxically, these industrial agricultural systems that emit more than 30% of greenhouse gases are very vulnerable to climate change. Actually, In 2022, there was the worst drought in the Midwestern United States, and approximately 30% of the corn production was affected. And therefore, it's kind of a paradox that this agriculture produces the greenhouse gases and at the same time is vulnerable to it. So what is expected in the future is that maize production, wheat production, rice production, depending on the region, is going to go down, which may actually also affect the cost of food. So interestingly, then this industrial agriculture, these monocultures, occupy 70 to 80% of the arable land, but only produces 30% of the food because most of the food that they produce is for cars, for biomass, and for animals, especially cattle. And this agriculture uses 70% of the water, 80% of the fossil fuels, and as I said, is largely vulnerable to diseases, pests, and climate change. So we have a challenge for the future. We need to increase production sustainably, but not to double production as many are saying, because actually hunger is not the problem to lack of food. Actually, in the United States, there are 2 million people that are hungry and about 40 million that are food insecure. It's a problem of poverty, access to food, access to land. There are other structural problems that are related to food, to hunger. There is also the issue of food waste. A US and European person throws away 115 kilos of food per year. And so there are other problems. But we need to increase production sustainably using the same arable land with less petroleum or more expensive petroleum, less water, less nitrogen in a scenario of climate change. And what we say is that this challenge cannot be met with the existing industrial agricultural model and its biotechnological derivations. It's like when Einstein said, you cannot solve the problem with the same mentality that created it. We need a new paradigm. So this is where we talk about the conversion of these high input monocultures based on pesticides, fertilizers, highly degrading of the ecosystem and human health, to a system that is much more sustainable, more diversified, that is very intensive in knowledge and also intensive in ecological interactions. And what we're looking for then is an agriculture that is decoupled from fossil fuel dependence, that have very low impact on nature, that are resilient to climate change, that are multifunctional. Not only they produce food, they maintain cultures, they maintain gastronomies, they provide ecological cultural services, and they are the foundation of socially just local food systems, because by the year 2030, 80% of humanity is going to live in cities. Cities of 10 million people are going to triple in number. And in order to feed a population of 10 million, you have to import 6,000 tons of food per day, which has to travel about 1,000 kilometers on average. So that's totally unsustainable. This global system has to give pass to what we call local food system. So what we're looking for is an agriculture that has high productivity and high efficiency. That means we need to create systems where crops and livestock and trees are all integrated with recycling rates that are very high, with very low dependence on external inputs and energy. And this is where agroecology emerges. Agroecology is a science that I will explain in a few minutes, that is contrary to the homogenizing proposals that threaten the natural order and the autonomy of farmers, distances itself from the agrochemical, corporate, biotechnological, and digital regime, reintroducing elements of nature and also indigenous knowledge in the creation for the creation of biodiverse, resilient, and sovereign systems. So agroecology is a science that creates a dialogue of wisdoms between what we have in Western science, in agricultural science, ecology, social science, etc., with the traditional knowledge. Farmers that have been farming for centuries, that have stood the test of time. And from that dialogue of wisdoms then comes the principles of agroecology, which then take different technological forms depending on the socioeconomic environmental context in which farmers are. So one of the key ingredients in developing the science of agroecology has been the traditional knowledge. We have in Latin America agriculture that's been around for more than 10,000 years, in the Andean region, in Mesoamerica, in the tropics. And these farmers throughout the world, the small farmers, these traditional farmers, these peasants, campesinos, contadinis, although they occupy 20 to 30% of the land, they produce 50 to 75% of the food that is consumed by the world population, using very little water, very little fossil fuels. And so every time we eat, we need to thank a small farmer, because industrial agriculture, as I said before, only produces 30% of the food that we eat. And these systems are models of resilience because they have been interacting with the environment, and they have created systems that have actually stood the test of time because they have resilience. For example, these systems in the high Andes, at 3,500 meters above sea level, these waru systems that were developed by the Incas, actually they prevent frost, because by growing the potatoes in this raised bed surrounded by water, and the water absorbs the heat during the day, releases it at night, and then they elevate the temperature, avoiding frost. Or these systems in Africa, the Zai, especially Mali and other parts, where indigenous women particularly have developed these systems of these half moons that they fill with compost, and then they grow the corn with very little water, because every time you increase 1% the organic matter in the soil, you can actually capture 20,000 gallons of soil water per acre. So all these methods, traditional methods, have provided very importance for agroecology to develop systems for the future. The genetic diversity, for example, that small farmers have. This is in Mexico, center of origin of corn, where there's thousands of varieties of corn and also beans, because they grow them together. And these systems actually, if you look at this graph, you see that their water efficiency, use efficiency is much greater. For example, under a normal scenario, when you have water, the modern varieties of the Green Revolution, the burlap varieties, actually yield more per acre, per hectare than the native variety. But when you measure kilograms per hectare per centimeter of water, then you can see that the native variety is much more efficient than the modern variety. So under scenarios of climate change, traditional varieties are far superior than modern varieties. So these farmers have developed a very complex knowledge. They know their plants, their soils, they have their own classification systems. For example, this farmer in Puebla, Mexico, is growing coffee, but in a forest where there's more than 150 species of plants in a very sophisticated, stratified system. And from this system, the farmers not only derive coffee, which they sell, but they also they get medicinal plants and many other plants for food security, but also for local markets and even for international markets. Unfortunately, the systems are being reduced and now to monocultures. This is in Colombia. You can see, for example, in the zona cafetera, there are still some traditional systems where farmers grow their crops in a forest, basically in an agroforestry system. But now there is a push by the market to grow in full sun. And then the systems not only depend on external inputs, because here in this forest, the leaves of the trees provide the fertilizer, the organic matter. The leaves fall down, they decompose, they provide nutrients for the coffee. Here in this system, you have to use these external fertilizers, which are pretty expensive. But the worst thing of all is that under climate change scenarios, under drought, which are becoming increasingly common in Colombia, for example, you can see the evapotranspiration, the loss of water under systems with very low shade or with exposed to the sun is very high compared to the loss of water in these agroforestry systems. So the farmers throughout Latin America and also many other parts of Asia and Africa have developed complex systems that have, for example, the milpa, which is the corn bean squash, the basis of Mesoamerican agriculture. These systems provide many interactions above ground and below ground. This is just one example showing that certain plants attract beneficial insects that control the pest. Certain plants like the beans fix nitrogen and give it to the corn. There's all kinds of interactions that are happening in the systems that allows the system to be much more productive. So there have been many studies called meta-analysis that show that when you compare polycultures, these complex agricultural systems with monocultures, the green bar means that it's a positive effect. And these are thousands of studies, scientific studies, that are reported through this meta-analysis, showing that in terms of soil fertility, crop yield, carbon sequestration, pest control, biodiversity conservation, pollination, etc., the green bars are superior in the complex systems, in the diversified systems than in the monocultures. And when you look at productivity, we use what is called the land equivalent ratio. If you compare, for example, a monoculture of grain crop, let's say corn, with fruits, you have two monocultures, or if you combine them, as you can see in the figure here, actually, when you plot the yields of these systems, you get a value 1.4, which means that you need 1.4 hectares of monoculture to obtain the same productivity of 1 hectare of polyculture. And then the other thing that the research has shown is that these systems are much more resilient to hurricanes and other type of climatic events. For example, the study that was done after Hurricane Mitch back in the 1990s in Central America, they found that the diverse farms on the right suffered less mudslides than an erosion that the monoculture farms. And they did a study of 1,000 of these farms, and they found that these diversified farms with agroforestry, soil conservation practices, etc., were much more resilient to the hurricanes. Same thing happened in Cuba after Hurricane Ike. They found that the more diversified systems were able to withstand the effects of the hurricane. They suffer only 50% damage as opposed to 90 to 100% in the monocultures. And the recovery rate of these systems was much higher in the diversified systems than in the monocultures. So we're learning lessons of resiliency from the small farmers. We want to understand why they resist the hurricanes, what are the principles, the mechanisms, so that we can design systems for the future. And then the small farmers are also converting their systems. For example, this is a family in Cuba, in Santi Spiritu. They were given land, 10 hectares, but they were conventional farmers growing monocultures of corn and tobacco. And after training in agroecology, they converted their farm into a very diversified system of protection against winds, but also they provide wood and fuel and and habitat for beneficial insects. They have rotations, they have intercropping, agroforestry systems. Well, the interesting thing is that this system, you can see the evolution. The orange line means the dependence of external inputs. They were highly dependent on external inputs, and then they came to a point where the system is self-sufficient. It doesn't require fertilizer, pesticides from the outside. The only thing it requires is labor and the management of the land with agroecological principles. And then they found also that they are very productive. They can feed with protein. The protein derived from 1 hectare, they can feed 34 people per year with an energy efficiency of 30. That means they put 1 kilocalorie and they obtain 30 in terms of food. Then means that the system is 20 times higher, if more efficient than the monocultures that have efficiencies of 1.5. And then, obviously, we need to work not only on the farm, but also on the landscape, because the farms are inserted in landscapes. Many times, the landscapes have been highly degraded. So we need to work not only at the farm, restore the biodiversity of the farms, but also we have to restore the biodiversity of the landscape. And this is where comes the field called ecological restoration. I don't have time to explain this graph, but basically, let me show you one example. This is a community in Colombia, in the Cordillera Occidental, near the Valle del Cauca. This community didn't have any water. So what they started was restoring the watershed, reforesting the watershed. Now they have enough water for 90 families, and also for agriculture and for animals. Once they restored the watershed, then they started changing their systems of agriculture from monocultures of arracacha, which is like a potato tuber, and they started converting slowly the system to coffee, but a coffee that has borders of titonia. This green plant is called titonia, which is a green manure. It's also fodder for animals, and also the flowers attract beneficial insects. And then little by little, the coffee is combined with other crops like avocado and citrus, and with the temporal shade of this Ricinus communis, which is a weed actually, but you can use it as temporal shade until you establish the system. So here they're cutting. You see the titonia they put it on the soil as a fertilizer. And now this is the picture at the end, where you have about 15 different crop species with the corridors of titonia, which is the fertilizer, basically. It's a green manure. They cut it, and then they put it back there in the soil. It sprouts, and the system is totally independent from external inputs except the labor that they use. So basically, what we're talking about is, for example, this is in Boyacá. You can see that you can have agriculture with corridors of different plants, and at the same time, you have to have the restoration areas. Not all the land has the capability for agriculture, so you need to restore ecosystems, and that matrix of natural vegetation is going to basically improve the performance of agricultural systems. Now, it is important to mention that agroecology can also be applied at the large scale. A lot of people say, well, this is good for the small farmers. What about the large scale, more commercial farms? Well, there's an example here again, from Colombia, in the sugarcane area of Valle del Cauca, Colombia. There is a plantation of agroecological sugarcane, where actually the intercrop between the sugarcane beans, this is called, it's a green bean, vigna, and then they use it as a green manure. And then after the sugarcane closes, they bring in the sheep that goes inside the sugarcane, eats the weeds, they produce manure, and that way they fertilize their systems to the point that the what is called the efficiency of use of nitrogen, they obtain 2.7 tons of cane per kilogram of nitrogen. So the cultures that use chemical fertilizers, where the efficiency is 0.6 tons of cane per kilogram of nitrogen. So definitely the systems are much more efficient. And then you can also, in the same farm, they have what they call silvopastoral systems, where they grow the cows under trees, under strata. It's like a building. It has the grass, and then it has a shrub called leucina, which provides protein. And then they have the shade trees, which improves the animal condition. These animals are much more happy in these systems. And when you go from there to there, you can increase the carrying capacity from 1 animal per hectare to 5 animals per hectare. And you can see in this graph here, I summarize it up above in English, where it says you need 45% less area to produce 69 more animals and produce 65% more milk. So definitely the systems are much more efficient, and the animal condition improves. And at the same time, there has been research showing that the emissions of methane of these animals, of these cows, is much less than in the monoculture grasslands. So just to finalize here a little bit, in order to, it's not enough to ecologize the agricultural systems. We need to break the industrial monoculture with agroecology, and we need to dismantle the control of multinationals over the food system and the neoliberal policies that maintain such structure. We need to transform the food systems. We need to provide space for the right to food. We cannot expect that food is under the same rules of a TV set or of a computer. It's a totally different commodity because it's a right, it's a human right, and for that, then we need to create a bypass because you see the food empires, these are the multinationals that control what the farmers are going to grow, what technology they're going to use, they make them dependent. And then at the same time, they're colluded with the supermarkets, the big supermarket chains that determine what the consumers are going to eat, what price they're going to pay, and so on. And so what we need to, in order to change the system is very difficult, but we can create bypasses. We can create agroecological territories where small farmers and consumers enter into solidarity networks and solidarity markets where there is exchange of money, but there is also other things that unite them, like love for nature, love for peace, love for family. And so they share other values. And these types of territorial markets are emerging all over Latin America. I imagine also in Asia and Africa, where you create kind of short circuit channels that are less vulnerable to price changes and to the collapse of the centralized supply chains when what happened with COVID, you remember, reducing the dependence of producers and consumers from large corporations. And so this is where the role of consumers, all of us, we all eat 3 times a day. We need to understand that eating is both an ecological and political act, that every time we support local farmers instead of the corporate food chain, we are creating socio-ecological sustainability and resilience in our communities. And therefore, we need to have more consciousness about the multiple ecological, social, cultural roles of peasant agriculture, and we have to be actively participating in creating and strengthening the local food systems and pressure the local and regional government to support agroecological initiatives. For example, in Latin America, we have many countries that have developed now national laws of agroecology. For example, in the case now, Colombia just developed one law, approved one law. The same thing is happening in Paraguay. In Brazil has one for many, many years. And one of the aspects of the national law of Brazil is that, for example, the school lunch programs, where 30% of the food that is served in the schools has to come from small farmers. And the government buys that food from the farmers and assuring them a certain income. There's more than 2,000 municipalities that are participating, and they are feeding about 45 million students per day. So the farmers have to be organized, in order to set up cooperatives to produce cheese and milk and all these things for the lunch of the children. And the children benefit in terms of their health because this food is much healthier. It doesn't have residues of pesticides and so on and so on. So we need to create agrarian policies, just like is happening, as I said, in Brazil, in Colombia. First of all, the prices have to be based on the satisfaction of human needs and not on economic benefits. We need to revitalize small. We also need to recover more adapted and resilient traditional varieties, and we have to diversify diets and nutrition. And so some of the recommendations for agricultural policies, we need to promote agroecological systems. That means that the extension and research systems of each country has to adopt agroecology. promote regional microenterprises that produce biofertilizers and biopesticides and things of that nature that can be produced locally, artisanally by farmers. Remove the incentives that promote the production and consumption of foods that damage the ecosystems and biodiversity. Account for the true cost of agricultural production, because actually industrial agriculture externalizes the cost. As I told you, in the United States is about $10 billion, the cost of the use of pesticides annually, and reduce food waste. And so in order to massify agroecology, first of all, there has to be a crisis. And what more crisis than that we're facing as humanity? Second, there has to be social organization. Farmers have to be organized socially, and as well as with the consumers. We need to create networks for sharing the experiences and knowledge between farmers. We have to have effective practices, agroecological practices, and we have to have markets where we have the alternative, solidarity markets, and as well as favorable policies that are going to be created. And these policies were not the result in Brazil or in Colombia of an illuminated government, but rather the pressure of social movements for years and years and years that led finally, in the case of Colombia with Petro now in power, that is much more receptive to these ideas, to become law. So this agroecological transition then means, in the end, to replace the corporate control over the land, seeds, water, and other productive and natural resources. So land reform is very fundamental. Here in Colombia, the government is buying the land from large-scale farmers to give it to small farmers. We need to promote local food systems based on cooperatives, reorient policies, research extension, and market incentives that favor agroecology. And finally, we need to evolve our agriculture so that it is able to be resilient to climate change and regenerate the natural resource base that is so degraded. So with that, I'd like to stop here and see if we can have a few questions or a few comments. I imagine we have 10 minutes. We can do that.